AWS Certified AI Practitioner. AI is the overall science of a computer being able to mimic human behavior, while machine learning, which is a subset of AI, is the science of learning from data to find patterns in them, which can be used to predict with new data. Deep learning is a subset of machine learning. Here we are talking of neural networks, kind of artificial representation of how human brain works. It could be used for computer vision, speech recognition, etc. So how does machine learning work? You feed training data to a machine learning process. It examines it to find patterns using a machine learning algorithm and outputs a trained model. And when you feed test or new data to this trained machine learning model, it makes a prediction or inference. Machine learning can be broadly grouped into supervised, unsupervised, and reinforcement learning. Here's an example of supervised learning. Input dataset has clearly labeled images of apples and mangoes. Our machine learning process learns from this and creates our machine learning model. Therefore, when a new mango image that it has never seen before is fed to the model, it is able to correctly identify it as a mango. Now contrast this with unsupervised learning. Here our input data consists of a bunch of unlabeled shapes. Our machine learning process tries to find patterns in this data and successfully identifies similar shapes. So here we can see that unsupervised learning is useful in finding data clusters in input data. In reinforcement learning, the model learns by receiving feedback on its actions from its environment in the form of a reward or penalty. So it learns by trial and error. Machine learning algorithms can be further categorized by the kind of problem they solve. So under supervised, we have classification, regression. Under unsupervised, we have clustering, dimensionality reduction, and for reinforcement, decision making. And here are examples of algorithms in each group. Let's take a quick look. Classification algorithms predict categorical labels or classes based on input data. So the examples of such algorithms are naive Bayes, random forest, SVM, logistic regression, KNN, decision tree, and so on. Regression algorithms predict continuous numerical values based on input features. For example, linear regression. Clustering algorithms group similar data points into clusters based on their features without prior labels. For example, k-means, dbScan. Dimensionality reduction reduces the number of input features in a dataset while preserving essential information. For example, PCA, SVD. In case of reinforcement learning, the model learns optimal actions through trial and error, receiving feedback in the form of rewards or penalties based on its actions. For example, Q-learning, R-learning, TD learning. So those are some important machine learning algorithms. To determine price of a product by features, you would use regression algorithm, for example, linear regression. To find customer churn, a yes or no kind of inference, you would use a classification algorithm like logistic regression. For sentiment analysis, which could be positive, neutral, or negative, you could use a classification algorithm like naive Bayes. And for anomaly detection in credit card usage, you could use a clustering algorithm like k-means. For a robot to learn to navigate a maze by trial and error, you would use reinforcement learning. Bias is model's systematic tendency to make consistently incorrect predictions. It often arises from limitations in the training data, incorrect assumptions, or inherent biases in the algorithm. Variance is model's sensitivity to fluctuations and noise in training data. Overall, the desired goal is low bias and low variance. Overfitting happens when a model has learned training data too well. It is unable to generalize on test data. The model has become complex. This is a case of low bias and high variance. Underfitting happens when a model did not learn enough from training data. Its performance is poor both on training and test data. It is a simplistic model. This is a case of high bias and low variance. Here are some fine-tuning techniques. Transfer learning, leveraging knowledge from a pre-trained model on a related task to improve performance on a new task. Data augmentation, creating additional training data by modifying existing data through techniques like rotation, flipping, or adding noise. Regularization, preventing overfitting by penalizing large model weights or randomly dropping units during training. Low-shot learning techniques. Zero-shot learning. Model performs on unseen tasks or classes without any labeled examples. One-shot learning. Model learns to recognize a class from just one labeled example. Few-shot learning. Model generalizes to new tasks or classes with only a few labeled examples. Text generation evaluation metrics. Blue. Bilingual evaluation understudy. This is a metric used to evaluate the quality of text which has been machine translated from one natural language to another. BERT score measures semantic similarity between text. Rouge or recall-oriented understudy for gisting evaluation. This is specifically designed for evaluating text summaries. Word error rate, primarily used in speech recognition to measure the accuracy of transcriptions. And perplexity measures the complexity of a language model. Classification evaluation metrics. Accuracy measures the overall correctness of predictions. Precision measures the proportion of positive predictions that are actually positive. F1 score, a harmonic mean of precision and recall, providing a balanced measure of performance. Recall measures the proportion of actual positive instances that were correctly predicted. Area under ROC curve measures the model's ability to distinguish between positive and negative instances. A metric for evaluating the semantic similarity between text generated by models and reference text is BERT score. Metric for evaluating text summarization models is Rouge. Hyperparameters are values that control the model's learning process or influence output generation during inference. They are not learned from data. Training time hyperparameters. Learning rate controls the step size taken during optimization. Batch size determines the number of samples processed at once during training. Epoch, the number of times the entire dataset is passed through the model during training. Regularization, techniques used to prevent overfitting. Optimizer, algorithm used to update model weights. A single pass through the entire training dataset during training is epoch. And what would happen if the model is trained for too many epochs? It can start to memorize the training data too closely, leading to overfitting. And if the model is trained for too few epochs, it may not have learned enough from the data, leading to underfitting. Inference time parameters. Temperature controls the randomness of the generated text. Top K sampling selects only the top K most likely tokens. Top P sampling selects tokens based on their cumulative probability. To get more diverse and creative outputs from a model, you could increase the values of temperature, top K sampling, or top P sampling. In simple terms, neural networks are computer programs or systems inspired by the way our brain works. They learn and make decisions from data, much like how humans learn from experience. Neurons are the basic building blocks of a neural network. You can think of them as mathematical functions that processes input data and produces an output. They are connected to other neurons through connections. Each connection has an associated weight that determines the strength of the connection. During training, these weights are adjusted to optimize the network's performance. A layer consists of a set of neurons and performs specific operations on the input data. They are one of the fundamental building blocks of neural networks. There are input and output layers at the edges, and the layers in between are called hidden layers. A model refers to the overall architecture or structure of the network. It defines how the layers and neurons are organized and connected. When artificial neural networks with multiple layers are used to learn complex patterns from data, it is called deep learning. It is a subset of machine learning. Here are some deep learning architectures. Generative adversarial networks. These are a class of machine learning models that use a competitive process to generate new data. Recurrent neural networks, a type of neural network that can process sequential data such as text or time series. Convolutional neural networks. a type of neural network that are particularly effective for processing images and other grid-like data. Stable diffusion, a diffusion model that is specifically designed for generative tasks such as image generation. To identify objects in images, use convolutional neural network. To generate images, use stable diffusion. Here's what a typical machine learning workflow looks like. Historical data is first cleaned, whereby records with incomplete or missing data, duplicate records, those with bad formatting are identified and corrected. Next, data is prepared. Here it may be split into training and test data. Post that, machine learning program processes the training data and creates a machine learning model, which is then evaluated using test data. The results are examined to tune the machine learning process further. Generative AI involves creating new original content such as text, images, music, and other media based on data the models were trained on. Types of Gen AI models: large language models or foundation models. Trained on massive amounts of data, large language models can generate human quality text. Multimodal models can process and generate multiple types of data such as text, images, and audio. Diffusion models uses a diffusion process to generate data, often used for image generation. Amazon Titan is a range of foundation models from Amazon. To generate text like summary, story, answering questions, translation, code generation, etc., you would use a large language model. Generative AI use cases: text, image, video, audio generation, text summarization, translation, chatbots, code generation, and so on. Natural language processing, or NLP, is a subfield of AI that deals with the interaction between computers and human or natural languages. It involves teaching computers to understand, interpret, and generate human language in a meaningful way. Natural language processing terminologies: token, the smallest unit of text that is processed by a language model, such as words or subwords. Chunking, breaking down text into smaller, overlapping sequences of tokens. Vector embeddings, numerical representations of data that captures semantic relationships. Large language model is a type of machine learning model that is trained on massive amounts of text data to generate human quality text. They can be used for various tasks like translation, summarization, creative writing, and answering questions. When you feed a prompt in natural language to a large language model, it responds in natural language. So, if you ask a question, a well-trained LLM will respond with a meaningful answer. Hallucination refers to instances where the model generates text that is factually incorrect, inconsistent, or nonsensical. Context window is the maximum amount of text the model can process and understand at once. Prompt engineering is the art of crafting effective prompts to elicit desired outputs from a large language model. Here are some types of prompt attacks. Jailbreaking, crafting inputs to bypass a model's safety constraints leading to prohibited or harmful responses. Prompt poisoning, introducing biased or misleading data into prompts to influence or degrade the model's output. Adversarial prompting, creating inputs designed to exploit models' weaknesses and produce incorrect or unintended responses. Amazon Bedrock is a fully managed service that provides access to foundation models from Amazon and third-party providers. It allows developers to experiment with different models and find the best one for their needs. Amazon Bedrock pricing models: on demand, pay as you go, provision throughput, reserved capacity, model customization. This is for training models. Amazon Bedrock Knowledge Bases allows you to create and manage your own private knowledge repositories. So if you want to use your private enterprise data alongside a foundation model, you would import that data into a knowledge repository. Vector databases are often used for knowledge repositories. Amazon Bedrock Agent. Given a prompt in natural language, Amazon Bedrock Agent can reason, use knowledge bases, perform actions, and generate natural language response using foundation models. It works with actions, knowledge bases, and a foundation model. Guardrails for Amazon Bedrock. These are safety features that control the behavior of Gen AI models so that they operate within defined boundaries. To prevent harmful or offensive content from being generated by a foundation model, you would use guardrails for Amazon Bedrock. Retrieval augmented generation is a technique to augment the knowledge of LLMs with external sources. In case of RAG, the user prompt is sent to an orchestrator, which may query a knowledge repository for additional information, and then a final prompt which is augmented with this additional information is sent to large language model, and the response received is returned to the end user. To access pre-trained foundation models over API, we would use Amazon Bedrock. To improve the quality of large language model responses by accessing external information, we would use Retrieval augmented generation technique. Vector databases are specialized databases for storing and querying high-dimensional vector embeddings. They enable fast semantic similarity searches, making them ideal for applications like recommendation systems and image or text search. Here are some vector-based storage and search services. Amazon OpenSearch, it offers built-in support for vector search. Amazon MemoryDB, this is an in-memory key value store that can store and retrieve embeddings efficiently. Amazon Aurora RDS Postgres. With a PG vector extension, you can create custom vector databases in them. Amazon Kendra, this is a managed service designed for enterprise search. It also supports vector embeddings. Pinecone, Milvus, VV8, and Qdrant. These are products which provide vector storage and search features. Amazon Q is a generative AI assistant that helps businesses automate tasks, generate content, and answer questions using their enterprise data. It ingests your data for processing using its pre-built connectors. With built-in security, the end users only see information that they have access to. Amazon Q is available in many flavors. Amazon Q for Business. This can be tailored to your business by connecting it to your enterprise data. Amazon Q Developer. This is for building on AWS. It is available wherever you work with AWS. You could use this, for example, to generate code. Amazon Q QuickSight. It enhances BI users' productivity to build visuals, summarize insights, answer data questions. Amazon Q in Amazon Connect. It helps customer service agents by using real-time conversations with relevant company data to automatically recommend agent responses and actions. Amazon Q in Supply Chain. It empowers supply chain professionals to ask intelligent questions, gain insights into their operations. If you need a service that allows businesses to create intelligent chatbots and search interfaces that can answer questions based on their enterprise documents and data, you would use Amazon Q Business. To assist developers with coding tasks and queries, you would use Amazon Q Developer. Amazon SageMaker is a fully managed machine learning platform that enables developers and data scientists to build, train, deploy, and manage machine learning models. Amazon SageMaker Components. SageMaker Jumpstart provides pre-built models and templates. SageMaker Studio, a web-based IDE for machine learning development. SageMaker Canvas, a visual interface for building machine learning models without writing code. SageMaker Data Wrangler prepares and cleans data for machine learning. SageMaker Clarify provides tools for analyzing model predictions and detecting bias, enhancing transparency and explainability. SageMaker Debugger provides tools for debugging and profiling machine learning models. SageMaker Autopilot automatically trains and tunes machine learning models. SageMaker Pipelines, service for building and automating machine learning pipelines. SageMaker Feature Store, fully managed purpose-built repository to store, update, retrieve, and share machine learning features. SageMaker Ground Truth builds high-quality training datasets with human-in-the-loop capabilities for improved model accuracy. SageMaker Model Monitor monitors the performance of machine learning models in production. SageMaker Endpoint hosts machine learning models for real-time inference. A visual interface for building machine learning models without writing code is Amazon SageMaker Canvas. To enhance transparency, explainability, and detect bias in machine learning models, you could use Amazon SageMaker Clarify. AI governance principles, explainability and transparency, risk assessment, data privacy, accountability. Tools that help with responsible AI. AWS AI Service Cards provides detailed information about different AWS AI services. Amazon SageMaker Model Cards documents and shares information about machine learning models such as their intended use, training data, and evaluation metrics. Responsible AI documentation providing information on use cases, limitations, design choices, and best practices for AWS AI services is provided by AWS AI Service Cards. Amazon AI Services, Amazon Recognition, Image and Video Analysis with Facial, Object, and Text Detection, Amazon Poly, Text-to-Speech Service supporting multiple languages and voice customization, Amazon Translate, translates text between multiple languages, Amazon Comprehend, natural language processing for sentiment analysis, entity recognition, and key phrase extraction, Amazon Transcribe, automatic speech recognition for transcribing audio to text, Amazon Personalize creates personalized recommendations using machine learning algorithms. Amazon Text Track extracts text, handwriting, and data from scanned documents. Amazon Forecast generates accurate forecasts based on time series data using machine learning. Amazon Lex build conversational interfaces. Amazon A2I, a service for incorporating human review into machine learning workflows. Amazon PartyRock, playground for exploring the possibilities of Gen AI. Amazon AI Healthcare Services. Amazon Comprehend Medical extracts medical information from text. Amazon Health Lake stores and analyzes health data. Amazon Transcribe Medical converts medical speech to text. To analyze customer reviews for sentiment analysis, you would use Amazon Comprehend. Let's look at some AWS services. AWS Config audits and manages resource inventory, config changes, and compliance. Amazon Inspector automated security assessment, vulnerability scanning, compliance checks for EC2 instances. AWS CloudTrail records AWS API activity for auditing of resource changes. AWS Trusted Advisor provides recommendations to help you optimize your AWS resources for performance, cost, and security. AWS Audit Manager manage and automate compliance audits. AWS Artifact repository of AWS compliance certifications, attestations, and reports. Amazon X-Ray request tracing for distributed apps, debug production issues. Amazon Macy identify and analyze sensitive data like personally identifiable information in your AWS environment. AWS Glue fully managed ETL service. Amazon Kinesis process real-time data streams. Amazon Elastic Compute Cloud or EC2 general purpose compute service. Amazon CloudWatch monitors AWS resources for metrics, logs, and events. Amazon RDS managed relational database. Amazon Aurora globally scalable high performance RDBMS. DynamoDB fully managed NoSQL database. Amazon Redshift is a data warehousing service. To record API calls made to AWS services, you would use AWS CloudTrail. Centralized repository of AWS compliance reports, attestations, and certifications is AWS Artifact.